Alright, so a bag contains 100 balls, numbered from 1 to 100. One ball is removed. What's the probability that the number on this ball is odd or greater than 180? So this is, you got a number 1, 2, 3, 4, all the way to 100 balls. All right. So they take out 1 out of these 100. So the question is, what's the likelihood that the one that you actually removed is not only odd, is odd, or greater than 100? Right, so if we go to the laws of probability here, we have a probability of A plus B. This is the probability that either A or B occur alone, or that both occur together. So this is the probability of either the ball being odd or the ball being odd, which is, greater than 100, greater than 80. Is that correct? Yes, greater than 180 alone, separately, or that both occurs together, meaning you can have a ball that's both odd and then greater than 180. So that's how we read this problem. So let's set it up first. So we have the probability of A plus B. Let's first, before we even start doing that, let's say that A is the event of the ball being an odd number. B is the event of the ball actually being greater than 180, right? So the probability of either or occurring is the probability of A plus the probability of B minus the probability of, what's the formula again? The probability that both A and B occurs at the same time. So meaning you have both an odd number, but the odd number is also greater than 80. AB, right? So what's the probability of the ball being odd number? How many odd numbers do we have out of 100? So it's half and half, right? So that'll be, remember, desired outcome over the total number of possibilities. So desired outcome is 50 odd numbers out of 100. So this is 0.5. Right? Now, what's the probability of the ball actually being greater than 80? How many numbers are, regardless of odd or even, how many numbers from 1 to 100 are greater than 80? So it's between 80 and 100, right? So that's 20 balls, right? So that's 20 out of 100. This is equal to 0.2. Now, what's the likelihood of the ball being both odd and then greater than 80? So between 80 and 100. How many balls do we actually have that's greater than 80 and at the same time odd? So we have 20 numbers. Half of the numbers is odd and half of the number is even. So if we count the number of the odd balls between 80 and 100, that'll be 10, right? So we have probability of both being at the same time. So we have, out of the 20 numbers greater than 80, it's half of it that's odd and the other half is even. So we have 10 out of 100 numbers that's both odd and greater than 80. So this is 0.1. From here on, it's just a matter of plugging. 0.5 plus 0.2 minus 0.1. And I got this problem from the NCES book as well. So this is 0.6. So this was a very interesting one, actually. I like this problem. So it's a you're applying the formulas and you thinking about it as well as you go through. This is a direct application of one of the laws of probability. What do you call this law again? Law of total probability. Yes. So this was a good one. I like this problem. So straight from the NCES practice problem book. All right, so let me know if you have any questions or if you have any comments for this particular problem.